Okay, gang, we're doing implicit differentiation on this one. So for the x cubed, you're going to get 3x squared. Now, you have to subtract the derivative of this, and students make mistakes here at this point because they just subtract the first term. So what I'm going to do is I'm going to put up a bracket to make sure that I subtract the product rule, because that's what's happening because you have a variable times a variable. Okay, the other way to do it is put the -3 with the x squared when you do the product rule. It's just up to you. So when I do the product rule, I'm just doing it off of this piece here. All right, so first times the derivative of the second piece. So derivative of y is dy dx plus second piece times derivative of first piece. And then, like I said earlier, I'm going to have to distribute the negative to both because you're subtracting the product rule here. Okay, plus, now we've got a product rule again, so I'm going to do the product rule of this. I'm going to keep the 2x together. I don't need brackets here because it's not a negative sign in front. Here you had to have the brackets. They were essential. Over here, if I put them, they're non-essential. All right, so product rule again. So first, times the derivative of the second piece. So the 2y is the derivative of the 2. And the dy dx is the derivative of the y. Okay, plus second piece times derivative of the first piece. Derivative of 2x is 2. And that's going to equal to 0. All right, I'm just going to put the negative through now. I'm going to change the order up when I want to, when it looks like it'll look nicer. I'll multiply the 2's here. Just going to change the order here. Okay. All right, so after you find the derivative, remember you have to go ahead and isolate dy dx, the derivative. So I'm now going to get all terms with the dy dx on one side. All right, so this has a dy dx, this one doesn't. So this one I'll put to the right side, this one I'll move to the right side, this one I'll move to the right side. Okay, so anything with a dy dx I keep, anything without a dy dx moves to the right side of the equal. Order doesn't matter, but you have to get your plus and minuses correct. Okay, so that was here and here. All right, now the stuff on the other side of the equal, that would be negative because it's on the other side. Positive because it's going to the other side. Negative. Again, order doesn't matter. Just make sure the plus or minus is correct. All right, let's factor out the dy dx. All right, let's divide off this binomial. Now don't get confused with the negatives or the order. So like your answer may not look like mine, but it could still be correct. Like for instance, I'm going to circle this because this is done. Well, there's a little bit extra something you could do, which is nice. I'll show you that in a second, actually. But what I was going to say is the negatives could be exactly opposite, meaning your answer could look like Okay, and that would be if I multiplied up down by a -1 to both sides. It would opposite the signs, but it would still be the same answer, right? Just slightly formatted differently. The other nice thing that I would suggest you do, you know, if something factors, you can factor it, but also common factors are nice to take out. So like a common factor here, I can see this real quick. You can pull this out. So any kind of like factoring you can do is always really nice. I was just sort of wondering if that went. Does that one go? Let's see. 3x, 2x, no, my brain put that in the wrong order. X, 2y, 1. What would this make? This would make -6. No, I don't see it. Okay, but you guys get the gist. Like any kind of factoring, you can, if you can do it, it looks really nice. And it's sometimes easier to, you know, if you have to plug into it. Okay, gang, so this is nice or this is nice. All right, catch you. Hope that helped.